In this video, we'll discuss about the rectifiers, that is the device which capable of converting alternating current into direct current, that is AC to DC. So rectifiers usually make use of the diodes, which is having the unidirectional conducting property. Basically, rectifier is an device that converts the alternating current into direct current and makes use of the PN junction diodes because it has the unidirectional conducting property. When PN junction is forward biased, it will conduct the electricity. Where it is reverse biased, it will not conduct the electricity. This diode behaves like a one-way valve, which allows the current to flow in a single direction, that is when forward biased. This phenomena of converting AC to DC is called as the rectification. There are basically two types of rectifiers, half wave rectifier and full wave rectifier. So let us take the two different types of rectifiers and what is the meaning of them. Basically, the type of rectifier that converts only the half cycle of the AC into direct current is known as a half wave rectifier. Basically, the alternating current has two cycles, positive half cycle and negative half cycle. So in half wave rectifier, only one half cycle is getting converted into DC and other half cycle is eliminated. Otherwise, on the other hand, the full wave rectifier, which converts the both positive and negative half cycles of AC, which converts both positive and half cycle of AC into DC. An example of this full wave rectifier is a bridge rectifier, and also it will make use of more than two diodes. The bridge rectifier is one of the example for full wave rectifier, which uses four diodes. They are connected in the form of Wheatstone bridge. We'll discuss that by discussing the concept of full wave rectifier. Let us take the half wave rectifier first. So this is the simple circuit showing the half wave rectifier. Here the input is AC and output should be taken as a DC. This half wave rectifier makes use of a single diode which is connected to the input AC signal. This AC supply is connected to a transformer, which may be step-down transformer, which in containing of primary coil and secondary coil. So this AC signal is fed to the circuit, and the top of the transformer is called as point A. The bottom of the transformer is said to be point B. This is the input voltage applied to the rectifier circuit. The output is taken across the load resistance RL, that is going out to be the DC current or direct current. So basically, this is the PN junction diode, this is P type and this is N type region. When the positive half cycle of the AC is given, this is the positive half cycle, this is the negative half cycle. This is the input AC representation by means of the sinusoidal form. When positive half cycle is given, then end A of the transistor become positive and end B of the transformer becomes negative. So when this positive terminal is connected to P region of the diode, then this diode becomes forward biased. When diode is forward biased, it will conduct the electricity so that current will pass through the diode and through the load resistance, the current will flow from this top end to bottom end or in the downward direction in the circuit. During the negative half cycle, the current direction will get reversed in input. Then end A becomes negative and B of the transformer becomes positive. So because of that, this negative terminal is connected to the P region of the diode, then diode is said to be reverse biased. So when diode is reverse biased, it will not conduct the electricity. So during the negative half cycle, there is no output. That means the current will not flow through the load resistance. Only during the positive half cycle, this diode will conduct and output will be in the form of this half wave, and a negative half cycle is eliminated. So that is the reason why this circuit or this type of rectifier is called as half wave rectifier. That means current will flow through the resistance only when the positive half cycle of the AC is fed to the circuit. During the negative half cycle, the current is not flowing through the load resistance. So always the direction of the current through the load is in this direction, that is in the downward direction, that is during only the positive half cycle. So that means that two directional alternating current is converted into single direction, the DC current. Okay, that is how it converts the bidirectional AC into unidirectional DC. So let us take what is the efficiency of the half wave rectifier. So basically the efficiency of the rectifier is defined as the ratio of DC power output to the applied input AC power. It is the ratio of output power divided by input power. So basically the electrical power is calculated by means of voltage into current, or it can also be represented by I square into R, that is square of the current and the resistance product. So this is the half wave rectifier we are using. So to derive the expression for efficiency, let us consider the input voltage is V equal to Vm sin theta, where Vm is the peak voltage and sin theta is representing the alternating nature of the current. Let Rf is the resistance of the diode and RL is the load resistance connected in the circuit. So total resistance connected in the circuit is the RF, that is the diode resistance, plus the load resistance. Now you can calculate what is the input power and output power. If you take the output power divided by input power, that is called as efficiency of the rectifier. Let us derive the expression for this efficiency. For half wave rectifier, the average DC current output, the output taken across the resistance, is basically the mean value of the current, that is given by IDC is equal to Im divided by pi. Okay, so that means only half cycle is taken as a output, only positive half cycle. Because if you take total cycle, that is in the complete one cycle, that means 360 degree, that is represented by 2 pi. Okay, but only half cycle is taken as the output in the half wave rectifier. That's why only the term pi is appearing. If total cycle is appearing as a DC output, then the total 2 pi has to be taken. But only during the positive half cycle, you are getting the output. That's why the DC current taken at the output is Im, that is peak current divided by pi, half cycle. Okay. Similarly, the AC input current is going to be Im divided by 2, because only half of the cycle is feeding as a input. Okay, the negative half cycle is eliminated. That's why the RMS value of the AC given to the input is Im divided by 2. Here Im is the peak current, that is the maximum current during the AC signal. Now the DC output power. So how do you calculate the power? It is I square into load. So in this circuit, the load resistance current connected is RL. The current taken at the output is IDC. So total power, that is DC power output, is IDC square into RL. That is current square into resistance. Similarly, the AC input power is given by AC input power PAC will be is equal to IRMS square into RF plus RL, where RF is the diode resistance, RL is the load resistance, because this AC is flowing through the diode also and flowing through the resistance RL also. So total resistance that is affecting the AC is RF plus RL. So this is the DC power output. This is the AC power input. Now you take the ratio of the output power divided by input power. So that is given by eta is equal to PDC divided by PAC. Output DC power divided by input AC power. So just substitute for PDC, that will be IDC square into RL. PAC is IRMS square into RF plus RL. Okay. So what is the IDC value? It is Im by pi. What is IRMS? It is Im by 2. Just substitute for IDC and IRMS. So that will give you Im divided by pi square into RL whole divided by Im by 2 the whole square into Rf plus RL. So here Im gets cancelled. So this will become 1 by pi square. This will become 1 divided by 4. So that will be 4 divided by pi square into the resistance RL as it is divided by Rf plus RL as it is. Okay, so this is the efficiency of the half wave rectifier because we have substituted for IDC and IRMS for half wave rectifier. So what is the maximum efficiency you can calculate or you can get from the half wave rectifier? Let us take that. So this is the expression we have obtained in the previous slide. That is eta is equal to 4 divided by pi square into RL divided by Rf plus RL. Suppose you divide this denominator and numerator both by RL, that will give you this RL by RL becomes 1. If you divide this denominator by RL, this will become Rf by RL plus RL by RL is equal to 1. So you'll get this particular expression. Okay, so that is eta will be is equal to 4 divided by pi square into 1 divided by Rf divided by RL plus 1. If diode resistance Rf is negligible compared to RL, usually the diode resistance is very small compared to the load resistance, then the efficiency will be maximum. Okay, that means if diode resistance is neglected, then you can get the maximum efficiency. So how do you get that? So then if Rf by RL is very less than 1, if Rf is very small, then this ratio Rf by RL will be very less than 1. Okay, then the maximum efficiency, you can neglect this Rf by RL term in the efficiency expression. So that will give you eta is equal to 4 divided by pi square. If you calculate that, that will be is equal to 0.405. That is the maximum efficiency of the half wave rectifier. So therefore, if you take the percentage efficiency, the maximum percentage efficiency will be 40.5%. That means only 40% of the input AC can be converted into output DC. The efficiency is only 40%. It is very less. So that is the reason why half wave rectifier having its own limitation that it can convert only 40% of the AC into DC. Okay, so that is the information about the half wave rectifier. In the next video, we'll take up the concept of full wave rectifier and efficiency of full wave rectifier and the bridge rectifier as well.